Welcome to Elementary Algebra. The book is by Harold Jacobs. I'm your presenter, Molly Crocker. We're on Chapter 1, Fundamental Operations. This material is copyrighted. Lesson 4 is about division, the world's favorite mathematical operation. I can't tell you how many teachers of arithmetic on the elementary level have admitted to me that they didn't really know how to do long division until they had to teach it to their class. You are not alone. I know that division is your favorite operation and that long division is especially appealing to most math students. Yes, I'm kidding. There are occasions to crank out a long division problem on paper, and if I had to do it, I would absolutely use a calculator to assist. More on that in Chapter 14. What you're looking at is an old method of handling long division using something called the galley method. It was used for hundreds of years. This shows a division problem from a 16th century manuscript using that galley method. The outline of the work was thought to resemble a boat, and students were expected to add artwork. The problem seems to be that very long number divided by that next very long number. The answer is on the rudder to the right. I think if you want to really know how to do galley long division, you should probably go do a web search for a video. When we are dividing, the result is called the quotient. There are two ways of thinking about division. Let's say you have a pocket full of candy that you picked up at a parade, and you want to divide it among some friends. Instead of counting the number of pieces of candy and doing the arithmetic, you can go around your circle of friends and give one to each. One for me, and one for you, and one for you, and one for you, until all the candy is gone. Some of your friends might get more than one piece of candy if the distributing, or might get more candy than some others of your friends if the distributing doesn't come out evenly. You could consider giving the extra pieces to a younger sibling. Here's another way. If we want to divide 12 by 2, then we keep track of how many times we subtract 2 from 12 before we run out of 2's. This looks like we were able to subtract 2 a total of 6 times. Here's a pile of pennies that I want to divide into 3 groups. I made 3 rows and kept adding pennies to the rows until I ran out of pennies. It looks like there are 5 pennies in each row. They are arranged into a rough tangle 5 by 3. Now I know how many pennies I had when I started. Here is another way. We just keep subtracting 3 from the group. I pull out 3 pennies and pull out another 3 pennies and pull out another 3 pennies until I have 5 groups of 3. Let's talk about how we represent division and what we call the parts in their various forms. When we write the problem out with the double dot division symbol, the first number is the dividend and the second is the divisor. On the other side of the equal sign is the quotient. That's the answer. When we write it as a fraction, the dividend becomes the numerator and the divisor is the denominator. On the other side of the equal sign is still the quotient. In the long division format, the number under the bar is called the dividend. Then the number out front is called the divisor. As you work out the problem, the quotient appears on the top. The quotient is the answer when we divide. What do you call the answer when we divide? The quotient. If your division came out evenly, then you can check your quotient using multiplication. If 15 divided by 3 equals 5, then 5 times 3 should be 15, or 3 times 5 should be 15. Let's talk about how we handle remainders. We have 3 ways of handling leftover parts when we divide. Those pieces of candy you could have given to your younger siblings. But if we're using long division, we can just write the remainder with the rest of the quotient. So when we have 11 divided by 5, 5 goes into 11 twice. And I subtract 10 because 2 times 5 is 10. And I get 1. So 5 goes into 11 twice with a remainder of 1. There are some cases where it doesn't make sense to do anything with the remainder. For instance, if you have a piece of fabric 11 yards long and 5 yards is required to make a costume, then you can make 2 costumes. The leftover fabric goes into your scrap pile or you throw it away. You're not going to make part of another costume with 1 yard of fabric. Let's say you have 11 pounds of pottery clay to distribute to 5 potters. Each gets 2 1/5 pounds. So we took that remainder, we put it over the divisor, and we made a fraction out of it. The decimal version of handling remainder is shown here, still 11 divided by 5. We add a decimal place after the 11 and some more zeros, enough zeros till we either get a 0 for a difference down at the bottom, or we find out we have a repeating decimal. In this case, we ended up with a 0 for a remainder, so this was a terminating decimal. Sometimes we don't get a difference of 0. We get a repeating decimal, as in this example. The bar over the last 2 digits in the quotient says that these 2 numbers repeat forever. Here is some of the language we use to mean division. I'm thinking you're catching on to this variable stuff and can handle it all in variables. But if you're having trouble, and even as a math instructor with some long experience, I sometimes have to stop and think about it. And it helps to figure out how to set a problem up with actual numbers. Working a problem I know how to do helps me set up one with bigger numbers or messier numbers, or sometimes with variables. The quotient of x and y, when we say that, we mean x divided by y. When we say x divided by y, we mean x divided by y. When we say x into y, we mean y divided by x. When we say x out of y, we mean x divided by y. Sometimes we'll say the ratio of x to y. That's the first number you said goes first. X divided by y. Then the word per sometimes tells us division. 360 miles per 12 gallons means 360 divided by 12. Now a word about arithmetic. You've used those double dot division signs since grade school, and that's another symbol we are going to leave behind. Instead, let's write it like we would in algebra, which means fractions. We love fractions in algebra. You'll see why as we go along. So x divided by y is going to be x on top and y on the bottom of a fraction. X into y means y on top and x on the bottom. Mixed numbers, however, are a bane of algebra. Why? Because we forget which operation is between the whole number portion and the fraction portion. If you say it out loud, you'll hear it. 1 and 4/5. This is confusing because in algebra, when we set 2 things next to each other, we usually mean to multiply them. But in that case, 1 and 4/5 would be 1 times 4/5, which would just be 4/5. And that's not what that number means. In algebra, we like top-heavy fractions, and so we are going to convert mixed numbers to top-heavy fractions. I know, you were told these are improper fractions. There is nothing improper about them. We like them that way because they do not confuse operations. You may stop calling them improper fractions. They are top-heavy fractions. Let's talk about how you write your fractions. Write them vertically. Don't use slashes and diagonals. Write your fractions with the numerator over the denominator. Here's an example of what not to do. If you had x plus 6, all of that divided by 5, and you wrote it as x plus 6 with a slash between the 6 and the 5, that could be mistaken as x added to a fraction 6/5. But the fraction bar acts like a grouping symbol for both top and bottom. So write them vertically so we understand what's on the top and what's on the bottom. We will stop using diagonal slashes to mean division. More on that in less than 7. Don't be ambiguous. Ambiguous, a word that means I'm not sure what you meant. Here are some sample division problems. Press pause and see what you can do with these before I show you the answer. Here are the first two. A truck can be driven 10 miles for each gallon of fuel in its tank. What will a trip of 120 miles require for fuel? So 120 miles divided by 10 miles per gallon gives me 12 gallons. You can read this. I'm going to let you do that. Here's the remaining two problems. We're still talking about the same truck. Let's summarize 1.4. The answer when we divide is called a quotient. Dividing can be thought of as repeated subtraction. You can stop using the double dot division symbol now. Use a fraction instead. Write fractions vertically. Don't use diagonal slashes to write a fraction. That's ambiguous. We like top-heavy fractions. I'm going to add here that though the parts of a division problem have the names dividend and divisor, that the word divisor is the one we'll hang on to the most. We don't use dividend very often in algebra. It's the number on the bottom of the fraction, the divisor. It's the number out in front of the long division symbol. It's the denominator. Dividend, divisor, quotient. We write them and those names appear in different ways depending on which version of division we're using. Phrases that mean division include, but may not be limited to, quotient, divided by, ratio, into, out of, and per. The order in which we divide matters, so be sure to translate properly. That's all for now.